Finding the tangent of a complex number. So, we know sine of x equals e to the ix minus e to the negative ix over 2I. Cosine of x equals e to the ix plus e to the negative ix over 2. To find tangent, we just have to divide these things. Tangent of x equals sine x over cosine of x. So, here we go. E to the ix minus e to the negative ix over 2I divided by, it's a big fraction, e to the ix plus e to the negative ix over 2. This equals, let's see, multiplied by 2. E to the ix minus e to the negative ix over e to the ix plus e to the negative ix. So now we can start finding the tangent of a complex number. So e to the I times a plus bi, focus, plus, minus e to the negative I times a plus bi over e to the I times a plus bi plus e to the negative I times a plus bi. This, you can say this equals e to the ai minus b minus e to the b minus ai, right, over e to the ai minus b plus e to the b minus ai. I did that right. Oh, almost forgot. There's an I over here. Yeah. So now we have to, since the denominator is a complex number, we have to split up the real and imaginary parts. So it'll take a little while. So hang in. First, we have e to the negative b times cosine a plus I sine a. And then we have minus e to the b times cosine negative a plus I sine negative a. And then dividing all of this by I times, here, can erase this, dividing all of this by I times e to the negative b times cosine of a plus I sine of a. And then we have, let's see, and then we have plus e to the b times cosine of negative a plus I sine negative a. One more. Yes. Okay. Here, let me rewrite this. E to the negative b cosine a plus I sine a. Okay. So now, we'll just work on the denominator. So for the denominator, we have I times e here. Denominator. We have I times e to the negative b cosine of a. And then we have I and I cancel out, so minus e to the negative b, we still have e to the negative b, sine a. And then we have plus I times e to the b cosine negative a. Cosine negative a is just cosine a, as you know. Sine negative a is negative sine a. Important fact for this. So now we have plus I times e to the b cosine of a, and then sine of negative a is negative sine a, so, but we also have an I, so we have minus, and then we have another minus from sine of negative a, and those cancel out, so we have plus e to the b sine a. So now you can write this as e to the b sine a, and then minus here e to the negative b sine a, and then for the imaginary part, I plus I times e to the b cosine of a. Here, you can erase this. E to the b cosine a. Plus, there's no minus, so implies it's a plus e to the negative b cosine of a. Pretty interesting right here. Let's see. Yep. Can erase this. So this is a denominator. I'm just going to rewrite it right here. Let's see. So, we're almost there. All we have to do is multiply by the conjugate. As you know, we have a complex number of the form a plus bi, or rather c plus di, because we already have a and b. Of the form c plus di, we have to multiply that by c minus di to get a real number in the denominator, which is exactly what we want. So, to do that, we're just going to have to multiply the numerator and the denominator by a number, right? X divided by x. You can multiply that by anything, it'll be the same. So as long as x is not 0, of course. So 5 times x over x equals 5, of course, assuming x is not equal to 0. And the same goes with complex numbers. So a plus bi times really anything over anything as long as it's not equal to 0 equals a plus bi, assuming x is not equal to 0. So, what we will do now is multiply the denominator by the conjugate, by its complex conjugate. So, we'll have to multiply the numerator as well. So, to multiply this by the conjugate, so e to the b sine a, here, parentheses over here as well, minus e to the negative b sine a, and then we have minus I times e to the b, there it is, cosine of negative a is cosine a, so cosine of a, cosine a, and then plus e to the negative b cosine a. Nearly the same, but not exactly the same. One more. Okay. Now to the denominator, I have to do the same thing. So it's pretty easy. It's for the denominator. So since we have plus, this gets squared Let's see. Yeah, this gets squared. And then we have to add the square of this. So, now that we have a real number in the denominator, we just have to work out the numerator. So, here, I will take a piece of paper, just to work it out. One second. Okay. We have this is the hardest part. Bear with me. So as you can see, right over there. Hold on. So let's see. E, focus, E to the B, sine of A minus E to the negative B, sine of A minus I times E to the B cosine of A plus E to the negative B cosine of A. Now all of this, we're going to multiply that by, you can simplify this a little bit more, E to the negative B. So E to the negative B cosine A plus I sine A, E to the negative B cosine of A plus I E to the negative B sine of A. And then, what do we have next? Oh, we have minus E to the B. Cosine of negative A is cosine of A. So minus E to the B makes it a bit easier to simplify. Cosine of A is simpler. And then we have I, and then we have sine of negative A, so minus I. But there's a negative over here and a negative over here from the sine of negative A, so they cancel out. So we have plus I E to the B, I E to the B sine of A. Now, we can do the multiplication. Oh, hold on. E to the negative B, this can be simplified. Cosine of A minus E to the B cosine of A plus I times E to the negative B sine of A plus, what is that? E to the B sine A. Okay. These are equivalent, so you can cross this out. So now we have the product of two complex numbers. So we can just, instead of doing all of that multiplication, we can just rewrite it like this. E to the B sine of A minus e to the negative b sine of A. Kind of hard to see, might be. And then we have, let's see, e to the negative b sine A. Yeah, times e to the negative b cosine of A minus e to the b cosine of A. Multiplication, right? And then we have complex numbers, so plus we have e to the b sine A minus e to the b negative sine A times I by all of this stuff. So we have plus I times, let's see, e to the b sine A minus e to the negative b sine of A times, let's see, e to the negative b sine of A plus, hold on, e to the b sine of A. And then, as you can see, we have this and this for multiplication. So we have minus I times e to the b cosine of A plus e to the negative b cosine of A. As you can see, I think you can see that, times e to the negative b, and then we have cosine of A minus e to the b cosine of A. Oops, here we go. As you can see, now we have to did all of that. Now we have that. So now we have the negative I times this times positive I times this. So I and I cancel out to make, negative 1. We also have a negative over there, right here. Makes positive, so we have plus e to the b cosine of A. You'll see this soon, e to the negative b cosine of A times e to the negative b sine of A plus e to the b sine of A. As you can see, that's just what I wrote down. Now, we just have to take this. We can do this on the whiteboard, I think. Take all of this, split up the complex, or the real and imaginary parts, and yeah, that's pretty much it. Let's see. So, yeah, it's okay. There we go. So, you can copy this on, just take real and imaginary parts, sort of separate them. It's okay. So, let's see. Okay, so now we have e to the b sine of A minus e to the negative b sine of A times e to the, negative b cosine of A minus e to the b cosine of A. And then we have, plus e to the b, okay, we have e to the negative b cosine of A plus e to the negative b by cosine of A times e to the negative b sine of A plus e to the b sine of A. Let's see all of that now. It's kind of bad, but yeah, okay. Let's see all of that now. And now we have the imaginary part. So plus I times, almost there. Plus I times, right? Okay, we have a big product. Let's see. B. Okay, so as you can see, we have e to the b sine of A minus e to the negative b sine A times e to the negative b sine A plus e to the b sine A. So we can rearrange, that to make it a plus b by a minus b, like x plus y by x minus y. So because of that, we can now do e. So we have e to the b sine A minus e to the negative b sine A times, rearrange that, e to the b sine A plus e to the negative b sine A. So we can square e to the b sine A, so e to the 2b sine squared of A. And then we have minus e to the negative 2b sine squared of A. Minus e to the negative 2b sine squared of A. As you can see. And then we have, what else? We have this. We have minus e to the b cosine A plus e to the negative b cosine A. And we have the same thing. E to the negative b cosine A plus e to the b cosine A. You can rearrange that, and multiplied by e to the negative b cosine A minus e to the b cosine A. Yeah. So now, you could just subtract, this stuff. That will be e to the 2b, if you multiply them together. E to the 2b, to the negative b cosine A, e to the negative 2b cosine A, cosine squared of A. And then we have minus e to the 2b cosine squared of A. Minus 2b cosine squared of A. Cosine A times cosine A, of course. And now we can just, let's see. Yeah, and now we're pretty much done. The 2b. Yeah, you can write this as difference of two big chunks. So now, draw a box. So now we found out the tangent of a complex number, since now that we have the numerator is a complex number and the denominator is a real number, so this works out well. And yeah, there's no need to use a calculator to find any trigonometric form of any complex number. So now we can just use a calculator to find the like for example sine of a, where a is a real number. There's no need to do sine of a plus bi or cosine of a plus bi.